Technology stories, augmented reality and virtual reality. Adoption of technology. The adoption of technology started early 1900s with telephone, TV, 1910s with electricity, air travel, and from 1970s to 2000s with radio, fridge, digital camera, and many more. The evolution of computers started from 1930s. Z1, which is large machinery, took an entire room space. Later from 1950s to present the hardware changed from transistor-based, integrated circuit bases, microprocessor-based to artificial intelligence in fifth generation. Source: Insider.com. Augmented reality was launched in 1960s, which used see-through HMD to present 3D graphics. Since 1997, AR's growth and progress have been remarkable. The first virtual reality headset invention was made by Jaron Lanier, founder of VLP Research, created iPhone head-mounted display in 1987. Augmented reality. Augmented reality, AR, is live view of physical or real environment which is augmented by computer-generated inputs such as graphics, sound, or object through specific tool. Examples: mobile/tablet, Cast R, Google Cast, Hologens, Sony Smart Eye Glass, etc. The benefits of AR is: it is cost-effective maintenance, hand-free, improved productivity, live expert support, easy to use, etc. Virtual reality. Virtual reality, VR, is a computer technology that replicates an environment that can be real or imagined. The user's physical presence can be simulated to allow the user to interact in that environment. Example: Sony PlayStation VR, Samsung Gear VR, etc. The benefits of VR is a virtual simulation of real scenarios, hands-free operation. But on the other hand, some key business points are its cost-effective training, production is expensive, and product is slight costly. AR versus VR. Augmented reality versus augmented virtuality. Augmented reality is applying computer-generated content into a live video or real user environment in real time. Keys: uses real-world setting and user can control the presence in the real world. Augmented virtuality is virtual or imposing digital information, experience like viewing a different world. Keys: completely virtual and the user's interaction is controlled by the system. Augmented reality types. 1. Marker-based AR. Marker-based augmented reality or image recognition uses our camera to identify the image and apply some visual marker, can be points or draw line/box, etc. It can be also used in QR/2D code to produce an outcome only when the marker is identified by our camera. Example: a mobile application with image recognition to find the object and impose a mark to measure its distance. 2. Location-based AR. Location-based augmented reality is placing an object as overlay on physical environment to recognize the location or display technique that overlays digitized information. It's used when location awareness capabilities. 3. Projection AR. Projection-based augmented reality means to have 2D or 3D hologram. In other words, the projection artificial light onto real-world surfaces. 4. Superimpose AR. Superimpose or imposes 2D or 3D virtual object on the real environment or physical object, placing a virtual object in live video. Our VR adoption. Exploring our VR an option for virtual training for students, employees, and customers. Industries use virtual automotive experience. User can configure the product in immersive experience. Some industries use our VR for planning and validation with technology-assisted process. Our VR plays a major role in the health industry. Applications such as body tracking, remote treatment, helps in diagnosis, etc. Our VR lifecycle. Our VR application development lifecycle have the following phases. 1. Requirement phase, understanding the project requirement, target analysis and its uses. 2. Design phase, design the application, UX/UI entire flow, review, and approve from client. 3. Development phase, coding and development to achieve the target feature including user interface, back-end services, and functionality. Make sure to follow the coding standards. 4. Testing phase. Tester or QA can evaluate the app performance manually or automatically for our VR apps. It can be tested using emulator or hardware. Report bugs for fix to development team. 5. Deployment phase. Launch or release the app after bug/issue fix to the market/store. Its deployment finalization and documentation process. 6. Maintenance phase. The application has to be maintained based on system updates, based on user feedback/review work on further fixes. Meanwhile, if any bug reports need to fix, it's periodic/intermediate major releases. Augmented reality apps. There are many applications developed with augmented reality concepts. Some of the few top augmented reality apps are below. Pokemon Go. This application developed by Niantic and targeted on portraying augmented Pokemon everywhere in the world. It lets in users to have interaction with different actual people in augmented battles with each other for the collection of Poke. Ink Hunter. Ink Hunter is one of the maximum popular unfastened applications available on each the Google's Play Store and the Apple's App Store. The utility lets you to area augmented tattoos in your body through your augmented reality camera smartphone, which allows the user to take a photo with that ink/art. Google Translate. Google Translate uses the AR camera to translate the language in the front of the camera into the consumer's desired preference of language. Virtual reality apps. There are many applications developed with virtual reality concepts. Some of the few top virtual reality apps are below. YouTube. YouTube has their own virtual reality application that allows the user to watch videos as system or computer-generated virtual world/environment with 360 degrees view. Google Cardboard. This is a must-try application that possesses a Google Cardboard headset. The application comes with inbuilt functions and features like Google Earth. Card enables the VR to predict the user's head position, and many other etc. Temple Run 2. It is one of the top games on both Google's Play Store and Apple's App Store. This game was redesigned to have a virtual environment created for users, allows to select scene and run/escape from the monster chasing them. Conclusion. R/VR demonstrations and case studies. There are POCs and solutions developed and demonstrated for industrial purposes. Some of them are aero engine maintenance, virtual car experience, cleaning robot design, chiller plant digital twin, chiller plant halogens training, etc. Case studies of Unity 3D. To explore the machine/products 3D view with all part description, demonstration and features. Some other studies like chiller maintenance application for iPad with back-end integration of Unity 3D to access data and other objects. Project support. For iOS or application project contract/support, reach me out email. bluemangaglobal@gmail.com. swift4cat@gmail.com. Connect me via LinkedIn.